Part two here of the periodic table for the eighth grade. Left off talking about the alkaline earth metals and how they, like I said, are they found in Earth's crust. That's why they're called the earth metals. Um, they are still reactive, but they don't react violently, and a little bit different color, a little silvery white instead of just silver. The next row, as you get in here, these are actually the B. We call these the B elements because they're the transition metals. Most of these are good conductors of electricity, malleable. You can be easily bent and hammered into wires or sheets. Just play focus to a couple of them here, as we got 26 is iron. Obviously, that's used in everyday material. And then if you look at this column right here, copper, silver, and gold, obviously very malleable, can be made into wires and not as reactive as the first two columns. Moving on, we get to this lower corner over here. It's going to be called the metalloids. Basically, here's our stair step that you go down. And with this stair step, what you find out is that these metalloids have some properties of metals and some properties of nonmetals. Silicon, anything that's going to touch that line in there is then going to be a metalloid. I know they don't show some of them in there. And then these ones down here, tin and lead, bismuth, thallium, and indium, these guys right here are going to be metals, but they're kind of called post-transition metals. But the metalloids are going to touch that red line that we saw on my periodic table. And then you got your nonmetals that we don't give specific names to, hydrogen that we left out on the first one, and then boron, carbon, nitrogen, oxygen. Sometimes you'd call this the oxygen family, but it doesn't really have a specific name like the other ones. But notice there's very little nonmetals, only about 12 to 15 nonmetals on the entire 100 and some periodic table of elements. Now, the column 7A, we do give a name. Those are called the halogens. Very poisonous, very reactive, just like the group 1A metals. In fact, a lot of times they end up bonding with each other, such as sodium chloride, which is salt. But these halogens basically mean salt forming, and a salt is a metal bonded with a nonmetal. So if we look at Na is a metal, chlorine is a nonmetal, we call that a salt. The last column are the noble gases. These guys are unreactive. Their outer shells are filled. They don't want to fill them up. And all of them are gases at room temperature, so we call them noble gases. The last two parts of the periodic table are down here at the bottom. That's called the lanthanide series, and it's not a column, it's the row. And then we got the actinide series going across on the bottom row. These would be more your orbitals that we talked about with electron configurations. These would be your F orbitals. Most of them are either man-made or very rare on Earth's surface. One of the main ones being uranium down here that's used as a nuclear fuel. So I just gave you a brief overview of the periods as we had looked at before. That's telling you how many shells to put in your Bohr model, and then how many valence electrons, which are going to be your B's up there. Just an overview of them all. Alkaline metals, alkaline earth metals, the halogens and noble gases are really the columns that you got to focus on, specific names. Metals to the left of the stair step, gave some nonmetals would be to the right, and metalloids if they touch that diagonal line that we looked at. That's the end of Chapter 5. Should be mostly review. If there's any questions, feel free to email me there. Don't forget to look at the full PowerPoint, the additional videos that we add, and any extra handouts. Hope you're doing well, and we will see you later next week.